Hi kids, now we'll be going with this paper discussion. We can look into the first question. A force of magnitude 35 Newton is applied on a two block system as shown in the figure if the coefficient of friction between the blocks is 0.2 while the horizontal surface is smooth. Okay, this surface is smooth. Then when you apply 35 Newton, what is going to happen? This is the thing. So in all these kind of questions, the better option is look at this 2 kg block. Look at the block where we are not applying force. When we apply force, what will happen? Okay, friction is not there, there will be relative motion. So if friction appears, so it will be on 2 kg block, it will be in the forward direction. On 7 kg block, it will be in the backward direction. Now, instead of this, let me see till what maximum force they can move together. Now, what is the maximum acceleration this can get? The maximum acceleration it can get will be only because of friction. So what is the maximum value of friction? Mu into 2g. Maximum value of friction is mu into 2g, so maximum acceleration will be mu g. Maximum acceleration of 2 kg block is how much? Maximum acceleration of 2 kg block is 2. So what does that mean? Till their acceleration is 2, they can move together. So with what maximum force I can push so that they will move together? They can move together only with the maximum acceleration 2. So 2 plus 7, 9, 9 to 18, m into a. So till I apply 18 Newton, they will start moving. They will be moving together, but when I apply more than 18, they won't be moving together. What will happen? This 2 kg will be moving with the acceleration 2 and this 7 kg will be moving with the acceleration more than 2. Now if I draw the free body diagram, I know this is moving its maximum possible acceleration. So friction will be maximum, mu mg. So friction is maximum. Now the net force is 35 minus 4 equals to 7 times of a. So acceleration will be 31 by 7 for this one, acceleration for this one is 2. Right. So from there, friction is 4 Newton, which is maximum, and they start slipping because only till you apply 18 Newton they will move together. Once you apply more than 18 Newton, 7 kg will move with more acceleration. In the figure shown, both the shells are conducting. Outer shell is thick and has a total charge q. The inner shell is thin and is earthed. So we need to find the charge redistribution. So this is the given question. Now what we will be doing, we will be drawing the charge redistribution. See, when I take Gaussian surface in the material of the conductor, electric field is 0, so flux will be 0, so charge enclosed will be 0. So on the inner side there will be 0 charge. On the outer side I don't know how much charge it is because it is grounded. Ground can give any charge, so I am assuming this as x. If this is x, this is going to be x because I can go with the same Gaussian surface. Total flux will be 0, so charge enclosed will be 0. So if this is x, this will be minus x. But the total charge on the outer one, it must be constant because it is not grounded. Total charge is q, they said. So if this is minus x, then this will be q plus x. Now this is grounded, so this potential has to be 0. Potential due to this charge will be kx by a. Potential due to this charge will be k into minus x by 2a. Potential due to this charge will be k into q plus x by 3a. So from there, when you solve, you will be getting the value of x. Once you get the value of x, you can just substitute and you can draw the new figure. It is going to look like this. From there, you will get all the answers. The next question, a nucleus undergoes series of decay according to the following scheme. Okay. So this is the given question and this information is given in the question. So you can go back. When you go back, like when there is alpha, there will be a difference of 4 and difference of 2. Right, so 143 and 59. So when you go back in beta, there will be a difference of 1. When you go back alpha, there will be a difference of 4 and 2. Beta, there is a difference of 1. So from there you can get all the answers. Fine. Two engines operate in series between heat sources and sink as shown in the figure. Heat source supplies 600 joules to engine 1 and efficiency 40% and engine 2 of efficiency 25%. Fine. So 600 joules, 40%, 25%. You need to find work done and efficiency. So this is given in the question 600 joules, but efficiency is only 40%. So work done will be only 240. Work done will be only 240. So out of 600, work done is 240. So ejected will be 600 minus 240, which is 360. Now this 360 will be utilized, but what is the efficiency? Only 0.25. So work done will be only 90. So the remaining energy will be 270. So work done by engine 1 is 240, they gave 360 which is wrong. Engine 2 is 90 which is correct. Efficiency of the complete system or heat rejected into the sink is 270, correct. Now efficiency of the complete system. Efficiency of the complete system is total work done by total heat taken. So 240 plus 90 by 600, which will be giving option C as right answer. An AC source is in series with RLC. Choose the correct options. Okay. So we need to draw the phasor diagram. Power at particular time. So instantaneous power they asked, and voltage of inductor. Instantaneous voltage of inductor. So first thing is we will be drawing the phasor. If I take current as reference, voltage in the resistor will be in phase, voltage in the inductor will be leading, voltage in the capacitor will be lagging. Now this resultant is going to be 6i, 6i, 8i will be 10i. But we know resultant of all this must give us source, so which is 50. So I am talking about maximum value here. So whatever I will be getting, that will be maximum value. How much is the maximum value? 5. So resultant of all this will be 10i, which must be matching with source voltage. So I maximum is 5. So I maximum is 5, and at the I maximum is 5, and I is lagging the source voltage by 37. Source voltage, so lagging this one by 37. So we will be getting omega t plus 37 minus 37 because lagging by 37. So if I want to write current, instantaneous current, then maximum value into sine omega t plus 37 and lagging by 37, so minus 37. This one and this one will get cancelled. So instantaneous current will be 5 sine omega t. So instantaneous power will be instantaneous EMF into instantaneous current. So instantaneous EMF given in the question, instantaneous current we have found. Now when omega t is 90, so given values when you substitute, it will be pi by 2. So when sine 90 plus 37 will be cos 37, and sine 90, 50 into 5, 250. So you will be getting the answer. Now apart from that, they are asking what is the voltage in the inductor. Voltage in the inductor. Now if you look at voltage in the inductor, this is the voltage in the inductor. So 12i. I is 5, I maximum is 5, so 12i will be 60. Now 60 and the angle is 53. So with respect to this one, it is leading by 53. So maximum sine omega t plus 37 plus leading by 53. So 37 plus 53 is 90, and this one when you substitute the time value, you will be getting 90. 90 plus 90, 180. 180 will be 0, right? A disc of radius 20 cm and mass 1 kg is rolling with slipping on a flat horizontal surface. At a certain instant, the velocity of its center is 4 and angular velocity is 10. The lowest point of contact is O. So velocity of point O and instantaneous. So we can look at the question like two parts. One is motion of center of mass, the other one is motion about center of mass. Velocity of center of mass is 4, so all the particles will be having velocity 4, plus it is rotating about center of mass, so this velocity will be r omega. When you substitute the values given in the question, that r omega will turn out to be 2. So this point will be this point's velocity will be combination of these two, so 4 minus 2, which will be 2, and this point's velocity will be combination of these two, which is 4 minus 0, 0. This is 4 plus 2, 6. So this velocity is 2, 4, 6. So we can predict instantaneous axis will be somewhere here, so which will be at rest. So if it is rotating with, if this entire body is rotating about this axis then let me say that is omega, and let me call this distance as x. So x into omega equals to 2, x plus 0.2 into omega is 4, x plus 0.4 into omega is 6 and stuff. So anyway, I can take only 2 because x and omega are unknowns. So x into omega is 2 for this point, x plus 0.2 into omega is 4 for this point. So two equations, two unknowns. When I solve x equals to 0.2, omega equals to 10 I will be getting. So instantaneous axis will be at a distance 0.2. So option A is correct because this velocity is 2. Option B is also correct. Instantaneous axis is at a distance 0.2. Angular momentum of the disc about instant IC over. So if you want to find angular momentum about this, then I into omega. So I for that is disc. So I about this axis is mr square, and you need to use parallel axis theorem, mr square plus m into this distance square, mr square by 2 plus m into this distance square into omega. That will give you option C as right answer. Now angular momentum of the disc about center of mass. Angular momentum of the disc about center of mass is mr square by 2 into omega. mr square by 2 into omega. That will give you option D. A capacitor of capacitance is connected to a battery of EMF 8 volt under steady state condition. Find the charge. So under steady state condition, what will happen? This will be fully charged and it will behave like open circuit. Once it behaves like open circuit, you can see what is happening here. This equivalent resistance is how much? 10 plus 10, 20. 20 is in parallel with 20, so 10. 10 plus 10, 20. 20 and 20 in parallel, so you will be getting 10. Equivalent resistance of this part is 10. Equivalent resistance of that part will be 10. So I can find the current, I can find this potential difference. This potential difference will turn out to be 4 volt. So this potential difference will be same as potential difference across the capacitor. So what is the charge on the capacitor? C into V, where V is 4 we got. Q equals to CV, V is 4 we got. In the figure shown, electromagnetic radiations of wavelength 200 nanometers are incident on metallic plate. The photoelectrons are accelerated by potential difference. These electrons strike another metal plate from which electromagnetic radiations are emitted. The minimum wavelength of the emitted photons are, so find the work function. So what is happening? You are sending some photon of energy. Now work function, some of the energy will be utilized to bring it out, and the remaining energy will be left as maximum kinetic energy. Now you are accelerating it, so that maximum kinetic energy you are increasing it and you are sending it here. So after hitting, they are asking minimum wavelength of the emitted photon. The meaning is, when will minimum wavelength happen? So when maximum energy of photon happen. So when will maximum energy of photon happen? Whatever the energy this electron is carrying, if the entire energy is emitted as photon, then that will be the minimum wavelength. So what is happening? You are sending this much energy, out of that some is going as work function. Now this remaining, this is the maximum kinetic energy. Now maximum kinetic energy, you are accelerating and you are giving extra energy. So now the total energy just before hitting will be this plus this. Now if the total energy is going to emit as photon, now what is the wavelength of the photon? Hc by lambda. So I think all the values are given other than this, you can get the answer. A U-tube has two tubes of radius 1 millimeter and 1.5 millimeter. What is the difference in the water level? So the figure goes like this. If the pressure here is P0, then the pressure here will be, pressure here will be more, pressure here will be less, and how much less? 2T by R1 less. If the pressure here is P0 minus 2T by R1, when you go down, pressure will increase, it will be this plus rho GH. Now similarly, if the pressure here is P0, the pressure here will be P0 minus 2T by R2. Now when you go down, pressure will increase, how much increment? Rho GH2. Now as this is in equilibrium, this pressure and this pressure must be, so this pressure and this pressure must be same. So when you calculate it, you will be getting the required answer. A ball of 0.01 kg is suspended from a fixed point by means of a light inextensible string of length 10 meter. Initially, the string is released from rest, from horizontal position. At the lowest point, it is hitting the stationary block lying on a rough horizontal surface. After striking the block, the ball rebounds and comes to rest by making an angle 30 degrees. Due to the impact, the block moves through a distance 0.5 meter on the horizontal surface if the coefficient of friction. Okay, so what is happening? You are leaving it here. So it will come here with speed. Now I can use energy conservation and I can get the speed as root of 2 GL, which will be 10 root 2. Now this is hitting the block. After hitting the block will have some speed and this one will have some speed. Now this is going and stopping here, and this is going and stopping somewhere. Now this kinetic energy is getting converted as potential energy. I can use energy conservation and I can get this speed as root of 2G L by 2, which is 10. So before hitting, the speed was 10 root 2. After hitting, the speed became 10. Now similarly, this is stopping after some time. So I can use the kinetic energy is going as heat, or kinetic energy is the energy is being converted as heat energy by friction. So work done by friction is mu mg into x. So from here I will be getting the mu value. Okay, so yeah, mu value as v square by 10. But v value how I can get? I know the initial momentum. Now during collision, momentum won't change. Because of collision, momentum won't change. So momentum just before collision will be same as momentum just after the collision. Momentum just before collision is this mass into this velocity. Momentum just after collision is this momentum into this mass into this velocity minus this mass into this velocity. This is the initial momentum equals to final momentum is this momentum minus this momentum. So from there I will be getting the value of v. I can just substitute it back. So what's happening? When it is coming down with a speed 10 root 2. After hitting, I can calculate what is this speed, because I know like what till what distance it is traveling. I have calculated this speed. Therefore I need to calculate this speed. In order to calculate this speed, I use momentum conservation. Once I know this speed, then I can calculate the mu value. A transverse traveling wave represented by equation. Find the kinetic energy of portion of the string of length equal to 1 wavelength. So this, okay, if you need to find the velocity of the particle will be dou y by dou t. This is the velocity of the particle. So kinetic energy of any element will be given by half into mass of that particle, which is mass per unit length into length of the element into velocity square, half mv square, half mv square. Now I need to integrate from 0 to lambda, that's what they asked. So you can do the integration and you will be getting the required answer. A source having a detector D moving towards a wall with certain velocity detects 9 beats per second. On doubling the speed, it is detecting 20 beats. The original frequency we need to find. When there is a source moving on wall stationary, like it will be emitting some frequency f0 and this will be listening some other frequency which is this much. Now due to reflection it will be emitting this frequency. Now that frequency will be heard by this guy like some other frequency. So this is the final frequency he will be hearing. Now this frequency, you can remember the result in some other easy way. It's like there is some object and image. If the image is also moving the same speed, then what will be the frequency heard by this guy? So whatever it is. So finally you will be getting this as the frequency. This is the apparent frequency. Now original frequency he will be hearing directly, which is f0. So beat frequency will be apparent frequency minus original frequency. So apparent frequency minus original frequency is 9 initially. Now when this velocity is becoming double, you are getting 20. So you can see two equations, two unknowns, you can solve for them, right? The diagram shows a modified meter bridge which is used for measuring two unknown resistance at the same time. When the first galvanometer is used for obtaining a balance point, it is found at point C. Now the first galvanometer is removed and the second galvanometer is used, which gives balance point at D. Using the details, find the value of 10 into R2 by R1. This is the initial figure given. So in this figure, this resistance into this length equals to this resistance into this length, like Wheatstone bridge, right? Now in the second figure, this resistance into this length equals to this resistance into this length. So you will be writing two equations. Now we don't need R, we need ratio of R1 and R2. So I will be finding R from here, I will be finding R from here, and I will be equating them. Then I will be getting the ratio of R2 by R1. A projectile is projected with a speed v such that magnitude of displacement of projectile in second and 7 second are same and are equal to 5 into root 217. So find the value of v by 10. Displacement in the second will be given by displacement in 2 seconds minus displacement in 1 second. Right, ut plus half at square minus ut plus half at square, which will be this much. Now displacement in 7 seconds is displacement in 7 seconds minus displacement in 6 seconds. But they said these two displacements are equal in magnitude. These two vectors are equal in magnitude. Now look at this one carefully. Now v bar plus 3 by 2 g bar, how I am drawing is v bar plus 3 by 2 g bar and v bar plus 13 by 2 g bar. Now v bar plus 3 by 2 g bar. So this is the displacement in the second. Now displacement in the 7th second is v bar plus 13 by 2 g bar. So but I know the resultant has to be magnitude wise this much. So I have drawn it down such that this magnitude and this magnitude will be same. So v bar plus 3 by 2 g bar, this is the displacement in the second. V bar plus 13 by 2 g bar, this is the displacement in the 7th second, and these two must be equal in magnitude. Now if this is 3 by 2 g bar, now by similar triangles I can say this must be 5 by 2 such that the total will become 13 by 2, and this value is given 5 root 217. And okay, this value now I know this value. By using the right angle triangle I can get this value. Now by using big right angle triangle, I know this value, I can find this value, right? A heater supplies constant power 80 watt to an object which have steady state temperature equals to 40 degrees Celsius. When the heater is switched off, the initial rate of cooling is 80 degrees Celsius and the rate of cooling on object is 5 when the temperature is 28. If the temperature of the surrounding is T, find the value of T. The body is receiving 80 watt initially. Apart from that, E sigma A T power 4 will be absorbed from the surrounding. So this is the total energy getting absorbed, which will be emitting back, E sigma A T power 4. I am converting into Kelvin, right? Now when they switch this off, what will happen? There will be net energy released. What is the net energy released? This minus this. Now that will be ms d theta by dt, the rate at which the temperature is changing, 8 they said. Now in the second case, when the temperature is 301 Kelvin, then 5 degrees Celsius per second they said, right? Whatever. anyway, change in Kelvin or Celsius is going to be same. Now, yeah, I think when I take the ratio, like E sigma A will get cancelled, I can take the ratio and I can get the answer 277 Kelvin, which is like 4 Celsius, right? Now, but in the solution they have done using Newton's law of cooling. When you take Newton's law of cooling, you will be getting the equation like this. Instead of E sigma A T power 4, you will be getting E sigma A 4 T naught cube into 40, like 40 minus T. Now, similarly in the other case 28 minus, see, I am taking in Celsius now, because Celsius or Kelvin the change doesn't matter much, right? Okay. So, when you take the ratio here, when you solve it, you will be getting the answer as 8, but out of these two, which is more correct? This is more correct, because this is an approximation. When will this approximation be valid? When the temperature difference is very small, but the temperature difference is not very small, right? So, this is the right answer in such cases. Unless until they say Newton's law of cooling is getting valid or stuff, then better follow this method. A solid cone made of material, relative density and height is floating there. Time period of oscillation, when you displace it and when you leave it, it will be performing SHM. You need to calculate what is its time period. So, first of all, it is like this, where this radius is r and this height is capital H. This radius is small r, I am assuming. This height is small h, I am assuming. So, I can say small r by capital R equals to small h by capital H by similar triangles or by taking tan theta. So, we will be getting this ratio r by r equals to h by h. Now, when it is in equilibrium, weight is balanced by buoyancy. Weight is density of the body into volume of the body into g. Will be balanced by buoyancy. Buoyancy is density of the liquid into volume submerged into g. Volume submerged is only this cone. Total volume is big cone, right? Now, from here you will be getting yes, this one value. Now, small r by capital R is same as small h by capital H. So, I can get small r by capital R value or small h by capital H value from here. So, till here it is fine. Now, why we are doing this, we will understand later. Now, this is the initial situation. Now, when you press it down slightly by distance x, what is the extra volume getting submerged? Extra volume getting submerged will be almost like this small cylinder. This small cylinder, what is the volume of this small cylinder? Pi r square is the base area into x. So, density of the liquid into base area into x, density of the liquid into extra volume submerged into g. This is the extra buoyancy. Extra buoyancy equals to mass times of acceleration. Now, acceleration is proportional to displacement, right? So, A equals to minus omega square x form. So, omega will be root g, right? So, omega is root g. So, time period will be 2 pi by root g. They said these two are equal almost, right? So, in all these cases, what we will be doing? We will be seeing like what is the extra buoyancy? Extra buoyancy equals to mass times of acceleration. A biconvex lens of radius r is made of variable refractive index mu equals to 2 into 1 plus 5 by d. Okay, radius is given. So, the image will spread and this y value is varying from 0 to d, 0 to d. So, refractive index will vary. When y is 0, refractive index will be 2. When y is d, refractive index will be 4. So, refractive index will vary from 2 to 4. If the refractive index is 2, what will be the focal length? If the refractive index is 2, focal length will be 1 by f equals to mu minus 1 into 2 by r, right? So, focal length will be 3.75. If the refractive index is 4, then the focal length will be 1.25. Now, where the refractive index will be 1.25? At these edges. These edges, refractive index, focal length is going to be 1.25. At the center, so focal length here is going to be 3.75, focal length here is going to be 1.25. Now, if I talk about the image because of this lens, where it will be getting formed, I will be using 1 by v minus 1 by u equals to 1 by f. So, I will be getting v as 7.5. So, because of this lens, image will be formed at 7.5. Because of the outer lens, image is going to form at 1.5. So, because of the outer lens, image is going to form at 1.5. Because of the inner lens, image is going to form at 7.5. Remaining lens, the image will be formed here. So, which is 1.5, 7.5. So, this spreaded image will be of length 6. A double slit experiment wavelength 2 millimeter fringes are observed. Okay, a transparent plate of thickness. It is found that the interference pattern shifts by 5 millimeter. The refractive index. Okay. So, in YDSC, if you take any point on the screen, any point on the screen, then the path difference will be this much, right? Now apart from this is the path difference when there is no slab. Now when there is slab, there will be okay, there will be extra path difference, or like depends on like where we are putting the slab. So there will be this path difference. This is the extra difference which is coming because of placing the slab. Now okay, we are going to see where it is going to be, where the central bright fringe will be formed. So this is the path difference because of, I mean, geometry. Now this is the path difference because of optical path distance, optical path, right? So when the total path difference is equals to 0, their central bright fringe will be formed. Where it is getting formed? They said where it is getting formed in the question, which is y is 5 into 10 power minus 3, right? So this is given in the question. From there you can get the value of mu. So the only thing you need to understand is we are just checking. Earlier central bright fringe used to form at y equals to 0. Now central bright fringe is getting formed at y equals to 5 into 10 power minus 3. So central bright fringe in the sense path difference has to be 0. Hi kids, okay, we'll be going with the second paper discussion. So look at the first question. A person riding a cycle at speed 18 km per hour along the equator. The wheel consists of 18 spokes and diameter. Okay, a bulb is attached between the center of the wheel and periphery. If the resistance of the bulb is something, then the power dissipated in the bulb. So you can clearly see, yeah, first of all, I think you can clearly see like it has something to do with EMF and stuff. So velocity I am converting it into SI units, and radius is 0.25. Now when something is rotating, yeah, when the wheel is rotating, then the potential difference between, then the EMF induced between midpoint to the circumference is half b omega r square. When you substitute, you will be getting this as the value. This as the value. Now why I have drawn this figure is, so in the equator, when cycle is going along the equator, then the magnetic field will be perpendicular to the plane of the bicycle wheel. So we can directly go with half b omega r square. If there is wheel like this, magnetic field will be perpendicular to it. So that's all. So then power will be E square by R. EMF value we have calculated, resistance value is given in the question, right? A hydrogen atom and helium plus are approaching with each other, towards each other with speed 2v and 2v respectively. The minimum kinetic energy that helium plus atom must have so that both the atoms can excite to first excited state. So first of all, the thing is, maximum kinetic energy loss will happen in perfectly inelastic collision. In perfectly inelastic collision, maximum kinetic energy loss will be half m1 m2 by m1 plus m2 into relative velocity square. Relative velocity in this question is 3v, right? So this is the maximum kinetic energy loss that can happen, but that must be sufficient enough to excite hydrogen to like the first excited state and helium plus to the first excited state. So what is the energy needed to first excited state in hydrogen? 13.6 into 1 by 1 square minus 1 by 2 square. So this is the energy. Now for helium plus, then this is the energy. So what is the total? Total is 51. So from where this 51 must come? This 51 must come because of loss in kinetic energy. So loss in kinetic energy must be giving us that required 51. So from here we will be getting half mv square. But what they asked what is the kinetic energy of helium plus? What is the kinetic energy of helium plus? Half into mass of helium plus into velocity of helium plus square, right? So that value you can get. Now here I have taken mass of hydrogen is m, so then mass of helium will be 4m. A point source of light S is kept at the bottom of the tank that has a liquid filled to height 2 meters. When seen from outside, yeah, okay, you can read the question, have the question paper beside you because I need to explain it using the figure. So they said something, when seen from outside, the source shifts by 40 centimeter. So shift is given 40 centimeter. T into 1 minus 1 by mu is 40 centimeter. Now total like length of the water is 2 given. So from there mu value we can find. So that information of shift is given to find the mu value. So that's about that line. So once we, that second line, that second statement is given to find the value of mu. Now what is happening? An opaque disc is placed where this length is 2 meter and this radius is 500 by 3 centimeter, which is 5 by 3 meter. This radius initially is 5 by 3 meters. Now it is increasing at a rate 2t. It is increasing at a rate 2t. It is in 2t centimeters per second, that is 0.02 t meters per second. Okay, so it is increasing. At a time t dash, it is found that the source can be just seen from outside. So that is this last ray we can see. So it's almost like we are blocking all the rays, all the possible rays. So for what radius we can block all the possible rays, that we will see. Now this is the last ray which can go out. So that is critical angle. If this is critical angle, this is critical angle. How to find critical angle? Mu sin C equals to 1 sin 90. So from there critical angle is 53. Once we know critical angle, then we can take this right angle triangle and we can take tan critical angle. Tan critical angle equals to adjacent by, tan is opposite by adjacent. So which is radius by 2. Radius by 2 is 4 by 3. Tan 53 is 4 by 3. So radius will be 8 by 3. So initially radius is 5 by 3. Now till the radius becomes 8 by 3, we can see it from outside. Once the radius becomes 8 by 3, we can't see it from outside. We can't see it from outside. So what is the time taken for that? Time taken for the radius to become from 5 by 3 to 8 by 3 will be 10 seconds. 10 seconds. Okay. Now we are not stopping there. We are allowing the radius to increase for even 10 more seconds. So after 10 more seconds, what is going to happen? After 10 more seconds, radius is going to become 17 by 3. Radius is going to become 17 by 3. Now once the radius is 8 by 3, we can't see. Now if the radius becomes 17 by 3, we can't obviously see the object. So what we will do, we will start pouring the water. When you start pouring the water, what will happen? This will start going up. So at certain point of time, we can see the rays again. So they are asking till what height we need to fill it so that we can see the rays again. We can start seeing the rays again. So once we are starting to see the rays again this ray, this is the critical, this is the last ray, like, right? So which we can see after, if you fill further more, then this ray will be going out. So in the critical case, I am just taking the grazing ray. So again, critical angle we have already calculated. Then again I can use tan critical angle equals to 17 by 3 by h. So h equals to 17 by 4. So I need to start filling the water till a height 17 by 4 so that I can see the rays again. So what is happening here? Initially we have put some radius 5 by 3, but we are seeing the rays, we started increasing. So once it became 8 by 3, we stopped seeing, but we didn't stop it there. We started increasing the radius even more, and after that we started filling the water. What height of the water we need to fill so that we can start seeing the rays again. That's the entire essence. In the diagram shown, modified YDAC is there. You need to find what is the fringe width. So basically in all these questions we will be converting one source into two sources. Now there is a source, if this is the source, and if I take image because of this lens, now 1 by b minus 1 by u equals to 1 by a. From there I will be getting image will be formed at 60 and magnification is 2, minus 2. Magnification is minus 2. So the meaning is, this is the principal axis for this lens. So I will be taking some imaginary arrow in this direction. If there is imaginary arrow in this direction, so the image will be formed here, which is at a distance of 60. So it will be inverted. So yeah, I think colors have been wrong. So if this is the object, then image will be here. This must be image because of this lens. Now similarly, if this is the object, then image will be here. Where this length is 0.2, this length is 0.2, and I mean this is 0.1. So this image will be 0.2. This is 0.1. So this image will be 0.2. Now this is 0.1. This is 0.1. So what is the distance between them? 0.2 plus 0.1 plus 0.1 plus 0.2, which is 0.4. So basically these two will act like sources now, which is at a distance 100 centimeter. So now you can see YDSC, where distance between two sources is 0.4 mm and this distance is 100. Then you can go with your regular formula, lambda capital D by D. Capital D is 100 centimeter, small d is 0.4 millimeter. 0.2, 0.4 plus 1 plus 1, 0.6, right? So the only thing is you need to understand how the two sources are getting formed. If the aperture of spherical mirror is not very small, the reflected ray does not meet at the focus even when they are incident parallel to the principal axis. This is referred as spherical aberration. It must be aberration. The reflected rays look like they are bounded by envelope of caustic curve. Assume the center of the sphere to be origin, radius of the curve to be a, and choose the correct options. So if there is center here, if the incident ray is making angle theta, this is angle of incident, so angle of reflection will be theta, and this will be going somewhere here. If this is theta, then this will be theta, because these two are parallel lines. So if this is theta, this will be theta. Now if these two are theta, then this will be 2 theta and stuff. So that is fine. Now we need to find this ray. So the equation of this ray, we know the slope is how much? Tan of 2 theta. So y equals to mx plus c, slope is tan 2 theta. Now I need to find the value of c also. For finding the value of c, I know this x coordinate and y coordinate. What is this x coordinate? This length is a, so its x coordinate will be a cos theta and its y coordinate will be a sin theta or h. Y is a sin theta or h, x is a cos theta. From there I will be getting the c value. Once I get the c value, I can just substitute it back. I got the c value, I just substituted it back to get the line equation. But they said it is curve, I don't know for what reason they said it is curve, but it's a line equation, fine. That's option C. Now going to option A. Now sin theta is h by a from the figure, from this figure sin theta is h by a. So once you know sin theta is h by a, you know cos theta, you can calculate tan theta, sin 2 theta, cos 2 theta, tan 2 theta and stuff. I just calculated everything because I need to substitute it back. So tan 2 theta I just substituted, sin theta cos 2 theta I just substituted, sin theta cos 2 theta I just substituted in the equation. So when I modified, I got option A. Now when it will be meeting the y axis, when y equals to meeting the x axis when y equals to 0. When y equals to 0, x value will be a square by 2 into square root of a square minus h square, but this 2 is missing in option B, so that's not correct. Now the other question, I think this has come in your other exam also. So when it is hitting at an angle 60 degrees, angle of incidence is 60. So if this is 60, this is going to be 60 and angle of reflection will be 60. Now if these two are 60, then if it, obviously like the other angle has to be 60, right? I mean this you have seen in the other exam also, so that you can manage it. Now this ray will be coming, hitting here, and it will be hitting at the, by symmetry it will be hitting here, thereafter it will be hitting here and it will be leaving parallel, right? The next question goes like, diagram shows a resistor in the form of frustum having resistivity and dimensions as shown in the figure disclosed, and the temperature of the room is T0. The temperature coefficient of resistance of frustum is 0, so resistance is fixed. Also neglect the change in the dimension of frustum due to heating. Also assume all the heat produced in the frustum is utilized in heating the frustum and only, and consider frustum to be black body. Choose the incorrect options. You need to choose what are the incorrect options. Now temperature of the frustum will keep increasing. No, see, when you start passing current, what will happen? It will start heating. Now see why it will it will be emitting energy. It will be heating and it will be emitting energy. Now at some point of time, what will happen? The energy taken by it will be equals to the energy emitted by it. So after that, the temperature is going to remain fixed. So increasing, which is incorrect. So we have to choose the incorrect option. So we will choose A. Maximum temperature achieved by the frustum will be independent of heat capacity. See, how we will calculate maximum temperature achieved? It's like the heat energy it is taking is going as radiation. So the heat energy it is taking going as radiation. In both of the equations, we won't get heat capacity. So maximum temperature doesn't depend on the heat capacity. So that is true, but we need to choose incorrect option. So we won't choose it. We need to find what is the maximum temperature and what will happen if we make EMF 4. So before that, if there is a frustum whose length, this length is L, then calculating its resistance. Now we will be taking some element, we will calculate its resistance and we will integrate it. So rho into L by area is going to be pi into this radius square. If this length, this radius is A and this radius is B, then this radius is going to be, I mean it is linearly increasing. So that much you can manage. So resistance of this element is going to be this much. When you integrate the resistance, you will be getting rho into L by pi AB, where L is this distance, but in the solution they have taken this distance. It's not correct. This I have taken it as capital L. Sorry, here it has to be capital L. Right, anyway, so once you get resistance, then you can get everything. Resistance is this though, so the power dissipated will be V square by R. Now where is this power going at maximum temperature? Whatever power it is taking, it will be emitting as radiation, then it will stop increasing its temperature. So that is the maximum temperature. So what is happening initially, whatever power it is taking is more, emitting is less, so it will increase its temperature. So power intake will happen. Now the power sending, radiating power will increase slightly because temperature is increasing. So intake power is constant, but emitting power initially was less. See, intake power is constant, emitting power is less, radiation is less. So what will happen? Temperature will increase. Once the temperature increase, then the radiation will increase. Once the again still, even now intake power is more, so temperature will increase, so the radiation will increase. Temperature will increase, radiation will increase. At certain point of time, what will happen? Intake power and outgiving radiation both will be equal in magnitude, so that is going to be like fixed temperature value. Till then temperature will be increasing. So what is how to find the maximum temperature? The incoming power equals to outgoing power. This is the incoming power. Outgoing power is E sigma A T power 4. Sigma area is pi r1 square, pi r2 square, and area of this lateral surface, which will be this much. I mean, I thought of attaching like why this came, but anyway you can manage. Sigma A T power 4. This is the net energy, right? Net energy emitted, that is body energy minus from the surface. Or you can do one thing, the energy taken because of the current and the energy taken from the surroundings. Energy taken from the current and energy taken from the surroundings is sigma A T naught power 4. This plus sigma A T naught power 4 equals to sigma A T max power 4. Now they said something in option C. Anyway, so from there if you want to find T maximum, then T naught will come into picture. T naught is anyway not there in option C, so which is incorrect, which we have to choose. Now if the EMF becomes 4 volt, becomes 4 volt, then also it won't become 16 times. So option D is also incorrect, so which we have to choose. Figure shows concentric spheres of radius r1 and r2 respectively. The space between them is filled with dielectric constant K and resistivity rho. The switch is closed at T equals to 0. Choose the correct options. Okay. So we can redraw the same figure. Now this resistance was put here and this EMF is put here, and from here to here it will be having capacitance and it will be having resistance. So there is a resistance and capacitance across the same potential difference. I can redraw the figure like this. Now I need to calculate the capacitance of this element and I need to calculate the resistance of this element. Now for calculating capacitance, what I will be doing, I will be giving Q minus Q and I will be finding the potential difference. So potential difference, anyway you people must be knowing it. So Q by V will give me capacitance, or you people will be knowing like what is the value of spherical capacitor. Now similarly, if I want to find the resistance, I will take some element and I will find the resistance of the element rho into L by A, and I will integrate. So I will be getting the resistance value of this much. So basically this is capacitance value, this is resistance value. I will be substituting them later. So now the maximum value of potential difference across the inner and outer sphere will be E, which is wrong. See, the maximum potential difference across this one is not E. When this is open circuit, the potential difference in this one plus in this one will be E. So in this one it will be less than E. So option 1 is wrong. Time constant. Now if you want to find time constant, then you need to find Thevenin's resistance. So that is short circuit this, open this and observe from across this. So when you visualize like imaginary battery, this resistance and this resistance will be in parallel. So Thevenin's resistance will be R into R dash by R plus R dash, which will be matching with option B. If you want, you can substitute. This R value is given as R in the question. This R dash value we have found here. So substitute it and you will be getting the answer. In steady state, current through R will be 0. In steady state, what will happen? This will become open circuit. So current through R is not 0. Maximum charge appearing on the inner and outer sphere is dependent on R. So potential difference across this one is obviously dependent on this R. See, once it becomes fully charged, what will happen? Some current will flow in this one and in this one. So I into R dash will be the potential difference here, but that I obviously depends on this R. So current in this one is obviously depending on this R, so potential difference across this one will obviously depend on R, so charge on this one will obviously depend on R. It depends on R, it is correct. A common type of viscometer consists of a cone rotating against a fixed plate as shown in the figure. Choose the correct options. Okay, so fine. So that's the figure, and they are saying about the first option, the shear rate dV by dH increases as we move outward. See, now if you take some element at a distance r, its velocity will be r omega in this direction, and if this distance is r, then this length is going to be r tan theta. So velocity is r omega and this height is r tan theta. So r omega is the velocity and the height is r tan theta. When you take when theta is small, tan theta will be almost theta. R and r will get cancelled. You will be getting omega by theta. So what they said, the shear rate increases as we move outward. So it doesn't depend on r. So it is going to be constant. It doesn't depend on r. But they said it is increasing. Actually, it is not depending on r. The meaning is it has to be same at any point. So first option is wrong. The torque needed to apply so that omega remains constant. So if you want to find the torque, now such elements, now I have taken at a distance r. Now how many elements will be there like that? There will be like circle of elements. Now if I take all the elements, how much will be the force on all those elements? It will be always tangential, right? Here velocity is in this direction, so viscous force will be in the opposite direction. Now if I take all the circular elements, viscous force will be along the circumference. So torque is going to be r into F. R into, what is that force? That force is, torque is r into force. Force is eta area. Area is how much? Area of that circular element will be circumference times of thickness. Circumference is 2 pi r and thickness is dr. Eta a into velocity gradient. Velocity gradient is omega by theta. That is the torque on the element. If I integrate, then I will be getting the total torque. When I integrate, I will be getting the total torque, which is proportional to r cube. The ratio of total torque to omega. Ratio of total torque to omega. Eta is constant, theta is constant, r cube is constant, is a constant value. So from here you need to find the eta value. Eta value will turn out to be this much, which is option D. Yeah, I think tau value, they didn't say what tau represents, but you must be knowing it must represent torque. Or when you go with the options, option C says torque, maybe tau you can take it as torque, right? A string fixed at one end and supported by a weight at the other end is oscillating in fifth harmonic when a body of mass m is hung at the other end using oscillator frequency. Okay. If we want the frequency of oscillator to be fundamental, okay, so see, first of all, I will be going with the given figure. In the given figure, what will be the fundamental frequency? For the fundamental frequency, there will be one loop is lambda by 2. Lambda by 2 equals to L. From there lambda I will get, from there I will get the frequency. This is the fundamental frequency, but they said it is operating in fifth harmonic. So what is fifth harmonic? 5 times of fundamental frequency. So 5 times of fundamental frequency, right? Now, okay. Now the same frequency, this V is root of T by mu, root of mg by mu in the first case. The same frequency must be fundamental in some other case where we will change the mass, The same frequency is fundamental. Fundamental is V by 2L. V is root of T by mu. This frequency must be fundamental for some other tension. Now what must be that tension? The tension will be 25 mg. When that tension will be 25 mg, when this mass will be 25 m. So option 1 is correct. Okay, so for F to be fundamental frequency, okay, so this 5 has to, okay, fine. We use a thick string in place of given string. If we use thick string, then this denominator is going to increase, then this one and this one. Okay, so you want to use it like fundamental frequency. Where you are not changing this. If you are not changing this, but if you want to use this one like a fundamental frequency, okay, this is mg, so this one has to become less. Now you can see this will become root of mu by 25, mu by 25. So the same thing I can write it like 1 by 2L into root of mg by mu by 25, mu by 25. So it has to become mu by 25. So it has to become thinner string. We can't use the thick string. We need to use thinner string where mu value is mu by 25. Now, okay, for the same case, if mu is fixed and if you want to use it like fundamental frequency, then this t value will be how much? 25 mg. This t value has to be more than mg. But when you submerge in liquid, what is going to happen? This t is going to become less than mg. So then also it won't become fundamental. On performing the same experiment on moon, the string will not oscillate in any mode. So when you perform it on moon, the fundamental frequency will happen. Will happen to be this much, 1 by 2L into root of t by mu. Thus t will be mg by 6. Now this is going to be the fundamental frequency on moon. So fundamental frequency is 1 by root 6 times of this one. This is the fundamental frequency on the earth. 5 times of this is given in the question. 5 times of this is given in the question. Now 5 times of this is not going to be any kind of frequency, because 5 times of this is not going to be any of the harmonic on moon. So it won't be making a standing wave there, right? Root 6 is coming, so it won't be any integer anymore. In the next question, we'll go with the options. So this is the situation. On increasing the acceleration potential, so there will be electrons coming out from here. So when you increase the potential difference between them, then soft rays will be converted into hard rays. So what will happen? When you increase the potential difference, the kinetic energy of the electrons will increase. When the kinetic energy of the electrons will increase, then the energy of photons emitted will increase. So soft X-rays will be converted into hard X-rays. The more the energy, we call them as hard X-rays. So option A is correct. Presence of K alpha ensures presence of K beta. When will K alpha happen? K alpha will happen when it is coming to first orbit from third orbit. When something is coming from first orbit to third orbit to first orbit, there is a chance of like coming from third to 2 and 2 to 1 also, right? So K alpha ensures there can be chance of K beta also. Now L alpha, make sure K alpha is also present. L alpha happens when electron will be like occupying the vacant place available in 1. So when electron is coming from second orbit to the vacant place in the first orbit. But this doesn't mean some electrons from third orbit will be coming into the first orbit. This need not be true, right? So when 3 to 1 is possible, 3 to 2 and 2 to 1 is also possible. But when they are talking about 2 to 1, there is no need of that possibility, like 3 to 1 must happen. On increasing the filament voltage in Coolidge tube, will increase the intensity of X-ray. So when you increase the filament voltage here, the number of electrons coming out will increase. If the number of electrons coming out is increasing, then after hitting, the number of photons coming will be increasing. So energy or intensity will be increasing. 1 mole of ideal monatomic gas is taken from A to B via some process and then B to C via some other process. Work done in process A, B and B, C and stuff. So in all these kind of questions, okay, they have given number of moles and degrees of freedom. So I am taking initial pressure is P0, when volume is V0 and temperature is T0. Now this process, from A it is taken to B and then to C. Now when it is going from here to here with the process, P T power minus half is constant. Volume is becoming 100 and temperature is becoming 100 more. So all these things I will be using gas law and I will be converted into PV power X is constant form, because PV power X is polytropic process and we can integrate it, but I know if it is a polytropic process, without integration I can calculate the work done NR delta T by X minus 1, where this is PV power X form. So N is given in the question, R value I know, so X value is minus 1, okay, and delta T is given 100. So from there answer will be 50 R. Work done in the first process is 50 R. Now similarly in the second process, TV power minus half, again I will be converted into PV power X form. Now I know the work done, but there is a problem here. NR delta T I don't know, so I am converting NR delta T as delta PV. Delta PV also I don't know, that is one more problem. P value they didn't give. So what I will be doing is I will be using this further information, TV power minus half. Now how I got TV power minus half? They said U is proportional to root V and I know U is proportional to T. T is proportional to root V. T V power minus half is constant. That's how I got this. Now this U I can write it as NCVT. Now from here CV is 3 by 2 R, so 3 by 2, nRT is PV, so from there P is 1 by root 3V. There P we don't know, so what I am doing, I am substituting P as 1 by root 3V so that I can get the variable into only V form. Once I get the variable into only V form, then I know everything because they gave the volume here and they gave the volume here. So you can just substitute the values and you can get the answers, right? In the next question, a solid sphere of radius r is centered at origin. The northern hemisphere carries uniform charge density rho naught and southern minus rho naught. Choose the correct statements. See, first of all, if I want to calculate dipole moment, what I will be doing is I will be taking some positive charge here and same amount of negative charge here. So this total q into this total distance, let me say q1 at r1 minus q1 at r1. So what is the dipole moment? Dipole moment will be q into 2r1. So q1 into 2r1. Now similarly, if I take other one, I will be getting q2 into 2r2. So I have taken 2 common, q1r1 plus q2r2 plus and so on. Now this looks like m1r1 plus m2r2 plus m3r3. This we have seen in center of mass. It is going to become total mass into position vector of center of mass, right? So what I can do, I can replace the total charge here at center of mass and total charge here at center of mass because the equation is looking similar. Now what is the dipole moment? Dipole moment is charge on this half into this total distance 3r by 4. Charge on that half will be density into volume of that half into the distance between them is 3r by 4. So that will give you option A. Once you know option A, then you can see all the other things. Now it's like a dipole. If you want to find the potential where theta is with x-axis, angle is theta, so with the dipole axis it will be 90 minus theta. Kp cos and angle with the dipole axis, which is 90 minus theta. So you will be getting sin theta, but they have given cos theta, so which is wrong. The value of electric field at q on x-axis. So if this is the dipole, if you want to find the field here, then it is Kp by r cube. So P value you just calculate it, you can just substitute, right? If an external electric field is applied on the sphere, so if there is an external electric field in this direction, if you rotate it, what will happen? The force on positive charge will be in this way, the force on the negative charge will be this way, so it will rotate. And what is the maximum kinetic energy? When there is a maximum potential difference. Now what is the potential energy in this case? In this case, electric field is this way, dipole moment is this way. So potential energy is minus PE. What is the maximum potential energy? Maximum potential energy will be, initial potential energy is plus PE, which is unstable equilibrium, right? Electric field is in this direction and dipole moment is in this direction. So potential energy is minus P bar dot E bar. P bar dot E bar is negative, so minus of that is going to be positive. So initial potential energy is PE and minimum potential energy will be in this position. So which is minus PE. So what is the maximum potential difference? 2 times of PE, or the maximum kinetic energy will happen when it goes from this position to the opposite position. So change in maximum change in potential energy is 2 times of PE, that will be going as maximum kinetic energy. A hollow sphere, okay, everything is heated, so you want to find what is the increase in the potential energy. So this is the initial situation. Okay, R value is 9 given in the question. R is 9. So, okay, R is 9 and this angle is 37, then I can use sin 37 and I can get this as 15. So that is fine. So center of mass of the sphere is at a distance 15 initially. Now when we heat it, what will happen? The center size is going to increase. So this 15 is also going to increase. And this 15, now the center, earlier the center is at 15, now the center will be at a distance 15 into 1 plus alpha delta t. Now similarly for the cone center of mass will be at a height 2h by 3 from the apex, 2h by 3. Now this h is 20r by 3, so that is, this is 5r, no? So you can use tan 37 and you can get this height as 20r by 3. So 2h by 3 is 2 by 3 times of h is 20r by 3. So when you substitute, you will be getting it as 40. So center of mass of the cone will be at 40. Center of mass of the cone will be at 40. Now that 40 will become 40 into 1 plus alpha delta t. Now what is the change? Initially it was at 15, now it became at 15 plus 15 alpha delta t. So how much increment? 15 alpha delta t. 40 40 into 1 plus alpha delta t, how much is the increment? 40 alpha delta t. So mg into increment is 15 delta t, mg into increment of the center of mass height is 40 alpha delta t. So mg h, mg h, increment, increment. So you need to add them and all the values have been given, you just need to substitute. A uniform glass tube of length 2 meter is closed at the lower end, it is completely filled with water and rigidly fixed. Now the tube is stretched downwards, although the length of the tube increases, the length of the water column remains, the length of the water column increases only by 0.08. So the tube is increasing by length 0.12, the tube is increasing by length 0.12, but see now this gap is 0.04. Even now the tube length is increasing by 0.12, but there is a gap 0.04. So how much is the water level increment? Water level increment is only of length 0.08. Out of 0.2, 0.04 is gap, so 0.08 will be water. Assume the water is incompressible. The meaning is volume of water in the both cases is same. So you need to find what is the Poisson's ratio of the glass. That's the definition of the Poisson's ratio, like change in radius by change in length by length. Change in length by length is given in the question. Change in length is 0.12 centimeter, by length is 2 meter. So now if we can find dr by r, then we can get the answer. Now if we want to find dr by r, they have given some information. Volume of the water is same in both the cases. If the radius is r in the first case, in the second case dr, I mean r plus dr. I am assuming increment, but it is decrement obviously. So volume in the first case is pi r square, you can take it like a cylinder, pi r square into L, pi r square into length is 2. So this is the volume of the water initially. Now volume of the water finally is pi into radius square, this is the area, into the length of the water. Length of the water is how much? Oh, okay, this 2 plus 0.08 centimeter. See, increment, I mean, yeah, you can see, right, this is 2.12, but out of 2.12, 0.04 is not water. So 2.12 minus 0.04 is 2.08, I mean 2 plus 0.08 centimeter. 0.08 centimeter is 0.08 into 10 power minus 2 meters. So what is the new length of the water? 2 plus 0.08 centimeter, which is 8 into 10 power minus 4 meters. So old length into old area equals to new length into new area of water. So both volumes are same because it is incompressible, they said. So from here you can modify, dr by r will be very small, you can use binomial approximation. From there you can find dr by r, magnitude wise you can find, and you can just substitute it back, right. The next question, you can read the next question. If there is a chimney falling, where it will break, that's the question. But if you want to solve the question, you need to understand the question like this, you need to visualize the question like this, like 2 dimension, you need to visualize the question like 2 dimension. So only then you will be able to understand what is happening. So first of all, when it is falling, when it is vertically and when it is falling, when it's making at an angle theta, when it's making an angle theta, it will be having some alpha and some omega. Because of drop in potential energy, omega will come. Because of the torque, there will be alpha. So let us calculate alpha. And now how many forces will be there? Weight will be there. I have resolved the weight into 2 components, mg sin theta and mg cos theta, right. So and apart from that, there will be normal reaction. I have taken, it will be having some ny component and nx component. I have taken this direction and this direction for easy understanding, because center of mass will have tangential acceleration and centripetal acceleration, right. So now I am finding alpha. Now how to find alpha? Torque equals to I alpha. When I take torque about this point, torque because of these two forces will be 0, torque because of this force will be 0, there will be torque because of only this force equals to I alpha. From there I will get alpha. Now apart from the drop in potential energy equals to increment in the kinetic energy, from there I will get omega. Now this is acceleration of center of mass, L by 2 alpha, this is tangential acceleration of center of mass, this is centripetal acceleration of center of mass. Now who is giving tangential acceleration of center of mass? This plus this, right. Nx plus mg sin theta will give me this acceleration. From there I will get nx value. Now similarly mg cos theta minus ny will give me centripetal acceleration. From there I will be getting ny value also. But this is not the thing. Now where it will break, right. So we need to see where the twisting is going to become maximum. Now what I am doing is, I am drawing the free body diagram like this, breaking it into some part. Now let me say this length is x, this length is x. Now how many forces will be there on it? Nx, ny, which are same as previous case. Now its weight components, sin theta and cos theta. Now what is its weight? Lambda into x into g. Now apart from that, this rod will be pulling it in this direction as well as in this direction. Now it is not a one dimension. If you visualize it like one dimension, we won't be getting the answer. So we need to visualize it like two dimension, because one dimension is not possible in reality. Now when you take like two dimension, now this nx will be exerting torque. Apart from that, this ny also will be exerting some torque. Now that torque, but when you take it like one dimension, you will be feeling like that ny is not exerting any torque. But when you take it like two dimension, there will be ny along this direction. So only the ny which is passing here, it won't be exerting any torque, but all these ny's will be creating some torque, right? So that's the thing you need to understand. Now, okay, now I am writing torque equals to I alpha for this. So torque because of these two forces will be 0, torque because of this one will be 0, torque because of this one seems to be 0, but it won't be 0. So I am calling torque because of this guy as tau y. So now torque will be because of this one and because of this one, and torque because of this one I am calling it as tau y. Now total torque equals to I alpha. I about this axis is m r square by 3 into alpha. Now I want to see when this will become maximum, but the problem is this nx I don't know. I want to calculate it and I need to substitute it back. So I need to calculate nx. So in order to calculate nx, what I have done, I have written net force along this direction equals to mass times of acceleration. Net force along this direction is this force plus this force minus this force equals to mass times of acceleration. So from there I found nx and I just substituted it back. Now I got only one variable, tau y. I need to see when it will become maximum. I need to see when tau y will become maximum. So tau y turned out to be something like this. Now eta, I have put eta because there are x and l. So I have called eta as x by l and I just substituted eta. Now I want to see when this will become maximum. If I want to see like when this will become maximum, I need to differentiate it and make it equal to 0, and I got the value as 1 by 3. 1 is minimum thing, 1 by 3 is maximum. So it is going to break at L by 3 from the base. But if you want to solve this question, you need to visualize it like a two-dimension body, because there will be some absurd things coming into picture when you idealize situations, right? So for example, like if a rod is if you hinge a rod, or like if you attach a rod to the wall, it will be in equilibrium like this. But when you try to write torque about the hinged point, torque because of weight will be there, but how it is in equilibrium. Now if you visualize it like a rod, like a one dimension body, we can't explain the equilibrium situation of that thing. So we need to deviate, we need to get into real life when absurd things are coming like that. Anyway, fine. The radius of curvature of meter gauge line at a place where train is moving and stuff. So those are direct questions, right? So when something is performing circular motion, net force towards the center is mv square by r, and this force will be balanced. N sin theta equals to mv square by r, and cos theta equals to mg. When you take the ratio, you will be getting the answer. Right? From there, you will be getting tan theta. Once you get tan theta, what they ask you to find? They ask you to find what is, if this length is 1, what is this length? So sin theta will be h by 1. Sin theta will be h by 1, but sin theta you can calculate from here and you can substitute, then you will be getting the value of this h. If this value is 1, what is the value of this h they asked? So for that we need theta. In order to find theta, we have used that circular motion thing. The next question, figure shows two blocks connected to a spring of spring constant 200 Newton per meter. Initially 2 kg block is in equilibrium. Now if 2 kg is further pushed downwards by 35 centimeter and releases, 5 kg block leaves after some time, what is the value of that time? See, if there is only 5 kg block on the spring, so spring will be at natural length. This is natural length. Now when I put 2 kg, it will be compressed and it is in equilibrium at this position, which is on the spring mg and kx. So kx equals to 2g, so x equals to 2g by k, or the compression is going to be 0.1 meters or 10 centimeters, fine. Now you are pushing it for, now this is the equilibrium situation. Now you are pushing it by 0.35 centimeter. 0.35 meters. You are pushing it by 0.35 meters and you are leaving it. So what is going to happen? It is going to perform oscillation with amplitude 0.35 meters. right? Now the good thing about the question is block, when will this one be lifting off? This weight is 5g, so spring force must be in the upward direction, or the spring has to be extended. If the spring is extended only, it will be pulling it upwards. So kx equals to 5g, so x equals to 5g by k. 5g by k is 0.25. So from natural length it has to go up by 0.25. The good thing about the question is you are compressed by 0.35 and it is going to 0.35 from the equilibrium. 0.35, 0.1 plus 0.25. So basically it is going from one extreme to the other extreme. It is going from one extreme to the other extreme. So you can see this is like a fixed wall and this is performing SHM. What is the time taken by this one to go from one extreme to the other extreme? It will be half of the total time, right? If it is performing SHM, this to go from here to here plus here to here is one time taken, but from here to here it is only half time taken. Now what is half time taken? 1 by 2 into 2 pi into root of m by k. Now what is m? 2, because this is not moving. So you can visualize like it, this is like a fixed wall and it is performing SHM, right? A block of mass 2 kg is released from point Q on a frictionless track. So you need to find the acceleration when the block arrives at P. So when it goes from here to here, it will be having some speed in this direction, okay? Now how to find that speed? I can use energy conservation and I can find that speed. Initial potential energy plus kinetic energy equals to final potential energy plus final kinetic energy. I will be getting that velocity, it's root 60, okay, fine. Now if it has some velocity and performing circular motion, there must be some centripetal acceleration. Who is providing that centripetal acceleration? Normal reaction. Now how much will be centripetal acceleration? V square by r. Normal will be providing that centripetal acceleration. Now apart from that, mg will be trying to pull it down. So what is the acceleration in this direction? 10. So centripetal acceleration is 12 and tangential acceleration is 10. So the resultant will be resultant of these two, root of 12 square plus 10 square, which will be giving you the answer, right? Thank you.